Now that we are familiar with trigonometric functions, let's dive in a bit more on their properties. Firstly, the trig functions are periodic. So what does that mean? A periodic function is a function that repeats its values at regular intervals. In more mathematical terms, we can say that there is a positive number p, where for every x in the function domain of f of x of p is the same as f of x. So, for instance, sine is periodic with a period of 2 pi. So one wave is 2 pi, and then after that, it repeats again and again and again. I can choose any point on the wave. If I go forward 2 pi, backwards 2 pi, or go forwards any multiple of 2 pi, I would be able to find the same value. Cosine is periodic too, also with a period of 2 pi, while tangent, on the other hand, has a smaller period of just pi. So using this knowledge, let's go ahead and solve this example. Cosine 80.25 pi. So, firstly, we know that the period of cosine is 2 pi. So we need to go ahead and write it in terms, let's try and pull out 2 pi from this 80.25 since this number is quite big. So we can go to cosine, and what I can do is I'm going to pull out the 0.25 pi and pull out the rest, which is just 40 times 2 pi. So 2 pi and any multiple of that, I can just go ahead and cross out since cosine is periodic. So in fact, this value is just the same as 0.25 pi, which is pi over 4. So in case you have forgotten your trig triangles, I can also just quickly draw it out. So pi over 4 is the equilateral triangle. And then I can see that cosine pi over 4 is simply 1 over the square root of 2. Let's take a look at more properties. Another property is a function may have is that it is even. Okay? So an even function is symmetric with respect to the y-axis. Basically, the output of a negative x is going to be the same as the output of a positive x. Okay? So an example of an even function would Another property a function may have is that it is even. So an even function is symmetric with respect to the y-axis. In other words, that would mean the output using a negative x is going to be the same as the output of that same positive x. So an example of an even function would be cosine. As you can see, the left-hand side is just a reflection of the right-hand side along the y-axis. And so cosine of minus theta is just the same as cosine of the same theta. On the other hand, an odd function is symmetric with respect to the origin. So in other words, if we were to reflect a function along the y-axis and then also reflect it along the x-axis, we would get the same shape. So in this case, instead of the output of a negative x being the same as a positive x, you would also need to put a negative sign in front of the entire function to get equivalence. So both sine and tangent are examples of odd functions, since you can see you would be able to get the left-hand side by reflecting both along the y-axis and then followed by reflecting along the x-axis. So again, knowing this, let's solve this expression over here. What is this value? Sine minus 25 pi over 6. So again, let's go ahead and pull out what we know about sine. we know sine is odd, and we know that the period of sine is 2 pi. Okay? So since sine is odd, we know that sine of minus 25 pi 6 is the same as minus sine 25 pi over 6. Okay? So from there, we can go ahead now use the periodic properties of sine to help us out now. So I'm going to split up 25 pi over 6 to be 24 pi over 6 plus pi over 6, which I can write out as 2 times 2 pi plus pi over 6. Again, I can go ahead and eliminate this multiple of 2 pi to get minus sine pi over 6. Okay? And then in case if you forgot what sine pi over 6 is, we can quickly draw out our triangle to help us out. Right? And then from here I can see that sine is just going to be half. And don't forget the negative sign that is right before it. So we're going to have this value to be minus half. Another type of question you may come across is finding the value of an angle based off of the lengths of the triangle sides, right? So far we've been able to find a missing side. What if we need to find a missing angle? And so to do that, we would need to be able to have an inverse of the trigonometric functions. However, we do have to remember that a function must be 1-to-1 to have an inverse. So in this case, the periodic properties of trig functions might be working to our disadvantage. It makes it that the trig functions are not 1-to-1. So how can we handle this? So what we'll do is limit the domain. Okay? So firstly, for sine, we can go ahead, look at the graph, and see that within the domain of minus pi over 2 to pi over 2, it is actually 1-to-1. It will pass the horizontal line test between these two numbers. Okay? And then what we can do in this domain, we can find an inverse. Okay? So to do this, we can do sine minus 1 of x to find the inverse. As we already know, the inverse is just a reflection along the line x is equal to y. And we have to limit the domain to be between minus 1 to 1, and the output itself will be between minus pi over 2 to pi over 2. So we're flipping the domain and range when we find the inverse here. Okay, and then since the output is limited to this range only, the question that you're solving may require you to find other possible angles based off of the periodic properties of trig functions. Okay. So let's go ahead and take a look at the inverse versus the others. So we have cosine. So again, for cosine, we need to find a domain that allows us to be a 1-to-1 function. And in this case, I am going to go ahead and limit it between 0 to pi. Again, the output is between minus 1 to 1. And we then will be able to get the inverse of that function. And then finally for tangent, what we can do is use the range minus pi over 2 to pi over 2 again. And this time, the output is actually, instead of being minus 1 to 1, it will be infinite. And so I can go ahead and find the inverse of tangent as so. So let's try a basic example. So here we have a right triangle. We're given two sides and we need to find the missing angle x. So firstly, looking at it, we can see we know the opposite and adjacents. So we'll be using tangent of x. And so tangent is the opposite over adjacent, which in our case is 20 over 4, which is equal to 5. Okay. So now what I'm going to do is I'm going to need to find the inverse of tan 5, which if I plugged into my calculator, I would get 1.373 radians. And that's it. We were able to find the missing angle using the inverse trig function. And so that wraps up this video for the properties of trig functions.